All right, so one of the fun things about teaching chemistry and being in chemistry is that it's a little bit like playing volleyball in the sand. I mean, anyone can play volleyball in a gym because, you know, your footing is always secured. It's a piece of cake. Physics is like that. Physics is like playing volleyball in a gym. It's boring. You take a step, and you can always be assured that there's going to be court there for you to step on. On the other hand, when you're playing in the beach, you're never quite sure that this step that you're going to take will be a nice, solid step, footing, whatever, and you might just actually fall on your behind. But on the other hand, if you're right next to the ocean, you get too hot, what can you do that you can't do on a court? So, I like chemistry because chemistry is always a little more interesting than physics, in that for every rule that physics gives you, there aren't any exceptions. For every rule that I give you, there are exceptions. So the rule of 8, we've been talking about the rule 8. Does it have 8? Does it have 8? It has to have 8. Well, no, it doesn't have to have 8. Okay? So, now we're to the point where we can look at some of these molecules that don't have 8, and not having 8 can also be great as well. I can recognize the common examples of octet exceptions. There are 3 types of exceptions. Molecules that have more than 8, molecules that have less than 8, and then there's molecules that have an odd number of electrons. How many of you, how many times did you count up electrons and you had an odd number? Never. But it is possible.
What do you mean an odd number?
You'll see. All right. Look at BCl3. BCl3. Boron is in the 5th column. For those of you who are still wondering, how does he know it's 5? 5th column. Chlorine is in the 7th column, times 3. What about the middle 10? We don't count those. How many times do I have to go through this? But I don't understand. I don't care! There's just 8 columns. I'm having a conversation with nobody. All right. How embarrassing. Sorry. Boron is in the 3rd column. I'm going to have to go back and edit this on YouTube so I don't look so foolish. All right, so 7 times 3 is 21, plus 3 is 24.
Those YouTube videos are pretty fun to watch.
Riveting.
They're filmed in here, so I know what everyone says.
BCl3, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Done!
No.
Is everyone happy?
No. Of course not.
Who's not happy?
Boron.
So when somebody's not happy, when the middle is not happy, what do we get to do?
Double bond.
Except we can't. Let me explain to you. Let's go back to dot diagrams. Boron has 3 electrons. 2 in the S, 1 in the P, right? Okay. It is possible for these electrons to move around a little bit. It's called hybridization. This is S2P1, right? It is possible for boron to increase its bonding sites by moving an S electron into the P. That is called hybridization. So this is called sp2 hybridization. Hybridization, sp2. It moved an electron. You could call it s1p2, but sp2 is just a shortcut. All right, s1p2 hybridization. Do you all understand that? In order for there to be a bond, you've got to give something, and they have to give something. All right, so we got B, which now has a potential for bonding how many times? 3, because you've got to donate 1 and they've got to donate 1. Chlorine has 7. So how many can chlorine donate? How many bonding sites does it have? 1. One. It shouldn't be, but here's the deal. It exists. So it has to be happy. But it violates the rule of 8. Yes.
You broke science, sir.
Okay, keep in mind that dot diagrams are a model. And models are our best explanations for trying to explain something. Okay? You can think of evolution as a model. Evolution is a model that tries to explain how we got here. Does it work perfectly? No. Remember Perry the platypus? Okay? Don't talk to evolutionists about platypus because their eye begins to twitch. A mammal that lays eggs and has a webbed feet and a bill. Okay, and they use the bill to suck milk from a mother. Okay, how about that? So, evolution doesn't explain everything perfectly, or else it would be a law. So it is just a model, just like the dot diagrams. So why do we use dot diagrams? Why do we use evolution? Because it's the best explanation that we have now. You mean we can come up with a better one? If you can come up with a better way of drawing these things that always works, then we will accept it. Okay? But for now, dot diagrams is all we have. And what does that mean? That means that boron only has 6 electrons in the outer shell. Now, unfortunately, I've confused a bunch of you because now you don't understand double bonding.
No, but it all looks like it looks like you wrote the same exact thing.
I did. I was just trying to explain it to you. I was trying to explain to you why you couldn't double bond it.
Okay. I thought you were saying it was
What?
How do you know that all of them are like that?
Okay, let me explain to you how carbon, if you were using carbon, it would have been a different story. Especially if you were using carbon and oxygen. Okay, carbon is like this. Right? S2P2. How many bonding sites can it have? If you must remember that in order to bond, you have to share one and somebody has to share one. 2. Why is this not a bonding site? It doesn't need anything. There's no compromise to be made here. Okay? But here are the facts. Carbon can bond 4 times. So, what we think is going on is that it's moving an electron. This is S2P2. It's moving an electron over, giving it the ability to bond 4 times. So now it's S1P3, or just sp3. This gives it an sp3 hybridization. An sp3 hybridization. Okay? Yes?
Previously, we were talking about how in order to be happy or kind of semi-happy, it had to have either half or full. In order for it to do this, to be less than an octet, would it have to so-called...
In this case, that fits because, think of it, you got half of S and half of P. So this kind of makes sense.
Will it always be kind of sense making, or is it crazy after a while?
It mostly makes sense.
Okay.
There's a little bit of craziness to almost every part of chemistry. Okay, so you've got carbon like this. And those of you who played Tinker Toys, this makes a whole lot more sense to you. Oxygen has 6. So it's like this, right? This oxygen also has 6. And it is, I need to erase this. And it is like this. Now, connect, right? But no one's happy. can we connect somewhere else? Double bonds. Boron did not have that option. Okay? Boron had this. See that? Boron only had that. It didn't have that option. So those of you who tried to double bond it, you really couldn't. Not really. The way I taught you how to make it really quick works 99% of the time, but doesn't work. In this case, it would betray us. Boron has only 6 electrons in the outer shell. Yes?
To figure out if it's an exception, do we have to calculate all these, like do all the little dots?
To figure out whether it's an exception, you just need to recognize, oh, boron. Uh-oh.
So boron's the exception.
Yeah.
Is boron the only exception?
Nope.
Nope.
Oh, that's great.
And the only exception that we'll use?
Wait, is boron
Check
the
this out.
exception to rule of eight?
Beryllium. It's a metal. Okay? So our tendency would be to put beryllium in brackets and it's +2 and 2 chlorines -1. It's ionic. It's ionic. This is how we do it. It's ionic. Yay! And you would be wrong. Beryllium is a metal, yes, but it is so tiny. It is such a tiny atom that you can kind of see its nucleus. Ooh. Which means it's kind of attractive. It has a high enough electronegativity to allow it to bond covalently. Okay? So, beryllium is the only metal that will allow you to bond covalently. Are there any other metals? No, just beryllium. Okay? So beryllium has 2. Chlorine has 7 times 2, 16. Okay? So far? Be 2, 4, 6, 8, 10, 12, 14, 16. Done? How about, is beryllium happy? No, it's not. Double bond! Can't. Okay. Beryllium is S2, right? How many bonding sites does it have? None. Where does it have one that it can share and one that it can share? It doesn't. It has 2, and you can't share 2. So it's done. But we know that beryllium can bond 2 times, so guess what it does? It hybridizes. So this is, what kind of hybridization is this? It is SP. So if it can bond 2 times, it's SP hybridization. This hybridization thing is going to be important. Chlorine can bond how many times? Come on, Tinker Toy people. How many times? Once. And this chlorine can bond how many times? It has 7. So how can it double bond? So, this is what I want you to do. I want you to take your pencil, your pen, and the box around beryllium and around boron, make it darker. And somehow you're going to have to remind yourself that that dark square means that it's an exception to the rule of 8.
Is there similarity?
What if there was like 4 electrons in, say like beryllium was a different element, and it had like 1, 2, 3, 4. Could you do the bonds on the top and bottom? Like,
No. No, it would need. This wouldn't work because you would need 2 more chlorines. This really wouldn't work. It would need to be BeCl4.
Is there some way an atomic mass have anything to do with this?
Atomic radius has something to do with it because of electronegativity, but not atomic mass. Okay, how about this? SF6. Sulfur.
Don't like this.
Yeah, so
How many outer shell electrons? How many outer shell electrons does sulfur have? No, it already had 6 to begin with. Now it's bonded and is sharing electrons.
yeah, on this 12.
Every dash represents 2, so how many outer shell electrons does sulfur have?
I don't like this.
Fact, SF6 exists.
I don't like it.
Fact, Lewis dot diagrams can't explain it.
Wait, why do we have to like represent it if we can't represent it? Like, why can't we just let it
Because it actually exists and will have, you'll see.
You know what I'm saying?
What
You'll
is
see.
SF6?
SF6 is a solvent. I think it's even also an explosive.
Blew my brain.
That was hilarious.
Thank you. Ow.
10.
Was that
I have
punishment?
10.
Ah.
Got it.
How many outer shell electrons? But wait a minute, that violates the rule of 8.
Isn't it annoying? You should just kill every time.
So, put boxes, heavier boxes around sulfur, selenium, and tellurium. They can bond 6 times. And phosphorus and arsenic. So we're not talking about a lot of elements that can do this. But I'm letting you highlight the ones that can.
So put those
Phosphorus
dark
and
boxes around phosphorus and
Okay. Remember what I'm telling you. Do not put a legend of what it means. Just heavy box it, and you're going to have to somehow remember that it's an exception.
not erasing anything, don't worry.
So could you go over
Hey,
their
so
So you see ASF5. You look at it and go, 5? If it's bonded 5 times, that's 10. It can't do. And you go, arsenic and phosphorus can do that.
so
so pretty much if it's 1 to 5, it has a
What?
so sulfur, selenium, and tellurium
Can bond 6 times.
and then phosphorus and arsenic can bond 5 times, and then beryllium and boron can bond
3 and 2.
3 and 2. Okay.
Okay?
No, sure.
Here's one of my favorite elements in all the world. I mean, not element, compounds. Compounds. Okay, it's called nitrogen monoxide or nitrous oxide. Back before the turn of the century, it was used heavily by dentists. It is. It's designed to just kind of relax you. So, I mean, you're already kind of anxious having to deal with a dentist, and nitrous oxide just makes you not really care to be there. Okay? Let's draw it. Nitrogen. 5. Oxygen. 6. 11. Right there, that should give you pause. How many times have we had an odd number of electrons?
Never.
Never is correct. Nitrogen, 2, 4, 6, 8, 10, 11. Is everyone happy?
Yeah.
No. Nitrogen's not happy. Nitrogen can bond can bond 3 times, so yes, you can do a double bond, but that's it. That's it. But Mr. Moreno, nitrogen only has 7 electrons. I know. But violet, yes, I know. But believe me, since I lived before the 21st century and I've been to the dentist, believe me when I say nitrogen monoxide does exist. I had my wisdom teeth removed and my parents couldn't afford to knock me out. So they gave me the shot on my molars in order to give me the local anesthesia, and then they put a little mask over my nose. Now keep in mind that I went there for a consultation before I had them removed, to go through the options and stuff like that, and for them to see that it was because my wisdom teeth were impacted. And I noticed, I was 20 years old, this is before I met my wife, so don't get all freaky. I noticed a dental assistant. Oh my goodness gracious, she was the most gorgeous creature I had ever seen. So, she's there, she's helping me, I'm going, you are so cute. I'm thinking that to myself. I'm not going to say, I'm going to be cool, be cool. So they give me this laughing gas, and they go, deep, and he goes, breathe deeply. I'm going, what's going on? Whoa. And I'm looking all around, and he's bringing all these sharp instruments, and I'm going, that's funny. And here she comes. And I'm thinking to myself, oh my gosh, you're the most gorgeous girl I have ever seen in my life. And she looked at me with a sweet smile and says, oh, that's really nice of you, thank you. And I thought to myself, she's telepathic too! And I started laughing because she read my mind. No, I said it. That's the problem with laughing gas. Whatever you think comes right out your mouth.
So you said she's telepathic out loud?
No, I was thinking to myself, I may have, I don't know. The dentist came out, my father told me that the dentist said that I was really funny. Because, I remember him going and getting my lower molar. I'm going, and out it pops. And I look at it, and I start laughing. That is so funny. All right. I don't quite understand paramagnetism, but you may get this question on the EOC. They may say, which of the following is paramagnetic?
Yes.
Okay? What you need to do is draw the dot diagrams. Okay? Neon is not. Magnesium is not. Oxygen is. Why?
Because it
Or any, it doesn't have any of the.
Unshared. If you were to take oxygen and liquid oxygen and pour it through a magnet, it would stick on the magnet. And the only explanation that they've been able to come up with is that this imbalance of having unshared electrons is what causes the magnetism. Nitrogen is even more magnetic or paramagnetic than oxygen. Can you tell me why? It is more imbalanced. It is more imbalanced. So paramagnetism is dependent on these bonding sites that have not been bonded. Okay, so if you have those, you're paramagnetic. Okay?